Knowing how to architect your application is a big deal when it comes to building a FastAPI product. We don't just want to build a backend application, we want to build something that is clean and easy to scale. So in this video, we'll be creating a FastAPI application that is following all of the best practices, which includes the domain layer, like where the entity development lives, the application layer, where all the business logic of the application lives, the infrastructure layer, which is where the database and rate limiting lives. And then we're also going to include all of the unit testing and end-to-end testing. This video will cover everything you need to get started with a clean architecture for your next product. If you're new to the channel, I'm Eric Roby, a software engineer with over a decade of experience, and I've helped over 100,000 developers learn and grow within their craft. All right, so with that, let's dive into some code. All right, so I already have a environment created. So I have a directory that's already created called clean architecture, which is hosting our application. Inside our directory, I just have a source directory with a empty main.py file. And then I have a requirements.txt file, which has all of our dependencies that we need to run our application in a production environment. So not necessarily what we need to run on our local machine, but what we need for a production environment. Now in my requirements-dev.txt, this is what we need for our development environment, which is like you right now on your personal machine if you want to code. So what we can do here is pip install -r requirements-dev.txt. This will install all the dependencies that we need for our entire project. So now what we can do is let's go ahead and jump into our main.py file. The first thing that we want to do is just add all of the imports that we're going to be creating in the future and that we need for this main.py file, which is just our database, our entities, our API, and our FastAPI. And then what we want to add here is simply our app, which is equal to FastAPI. And then we're going to have this base.metadata.createAllBind=engine. This we only want to uncomment when we're creating new tables when we run our application for the first time. This will break our tests later on, so I leave it uncommented, but it is a good thing to have just in case you want to rapidly be able to create new entities. Perfect. Now we're going to get a bunch of errors, and that's okay because we're going to be building everything step by step. Now, the next thing I'm going to just implement, just so we have all of our configurations down pat, is something called logging. So I'm going to create logging.py, and inside logging, it's going to be a way for us to be able to document kind of all of our endpoints. So if something happens in production or happens on our environment, we don't have to necessarily jump in and start debugging everything with code. We can go ahead and just kind of look at the logs that our application is creating and just be able to identify, hey, that's where the error is just by looking at the terminal. So in here, I'm going to add this logging, which we're going to import logging. We're going to import an enum from our string. And then we're going to just have this log format debug, which is showing us how our log is going to format debugs. And then we're going to have our log levels, which is going to be info, warn, error, and debug. And what this does is when we add these into our code, it'll tell us like, hey, this is just information. Like maybe this is just something that you might want to know. We might be able to like, hey, this is a warning in our code. If this happens, this is specifically going to cause downstream effects. Then there's like error, like our application's broken, and then we can have debug errors for like in the future. So if you have like an object that's getting weird, we can just throw in a debug. So then when we're running our application, it'll be like, hey, this is the object debugged. Now what our configure logging does is it takes in one of these log levels, and then we kind of just do different things. So it takes it, makes it capitalized, which already is capitalized. We find what level it is in our log levels, and then we're just kind of setting up different permissions based on the log level. And then we just enable our basic configuration to be logging. And if you've never logged before, we're going to be implementing this in our application, so you'll be able to see exactly what's happening. But overall, this is what it's going to look like when you want to set it up from scratch. The next thing we're going to be setting up is our rate limiting. So inside our source directory, let's go ahead and create a new file called rate limiting. And inside here, we want to implement our slow API, which was what we installed. Now, this will allow us to be able to do rate limiting on an endpoint. So what that means is we are saying, hey, Maybe our register, we only allow a certain user to be able to hit our register 3 times before maybe we're saying you need to take a break. And this allows us to protect from like DDoS attacks or some other kind of attacks where people are trying to spam or use bots to call our endpoints over and over and over again just to kind of collect data. We're putting rate limiting on, and this get remote address means it's going to collect the IP address. And we're going to say, hey, based on your IP address, we are not going to allow you to call certain endpoints, X number of times, because it could be security, maybe the endpoints cost money. It's something just to be like, whoa, slow down. You're calling way too many endpoints way too fast. So that's what we're implementing right here. And then we're going to be adding it in our endpoints here in a little bit. And now what we want to do is make sure we make this a Python package by saying __ init__.py. That means we can now call these very easily within our project. And now let's go ahead and create our first package. Now our first package is going to be called entities. Now let's go ahead and just say entities. Just like we did before, inside entities, we need to say new file __ init__.py. That makes entities a Python package. And now in this project, we're going to have 2 entities, one for our to-dos and one for our users. So we can go ahead and create 2 more files in here, to-do and users. Now first, let's go into our todo.py and let's add some code right here. So what we're saying is we are simply going to be adding our SQL Alchemy. We're going to be using UUID for our primary key, and then we're going to be using date time and some other things in here. So here we're just saying what the priority of this to-do is, which is going to be 0 to 4. We're going to create this now to-do class, and we're going to name this table to-dos plural. We have an ID of column UUID as UUID is true. It's going to be our primary key, and the default is to use the UUID 4. We're going to have a user ID, which is going to be a foreign key back to the users, which we haven't created yet. And that's also going to be a UUID. Then we're going to have description, due date is completed, created at, and completed at, and then our priority, which is going to be part of our enumerations up here. And then simply, we're just going to have this string, which returns all the data inside. We now want to do something very similar for our users, where we're going to have a new table of user, which is going to be called, and this table is going to be called users. Our ID is also going to be a UUID. And we're going to have an email, first name, last name, and password. Now, the only difference is we can see that it's the to-dos have a foreign key back to our users, but our users don't have a foreign key to our to-dos. And that's because it's a one-to-many relationship. There's only one user who can have multiple to-dos, but these to-dos can't have multiple users, right? So we're going to have one user that can hold multiple to-dos. Now, the next thing we're going to add is this database. And I kind of want to put this in its own folder, which is going to be called database. Now, inside our database, we're going to create a new file of __init__.py. And inside here, we're going to create a new Python class called core.py. Now, this is going to have quite a bit of information inside. So we're going to have everything we need. We're going to load from our .env if you want to stick this URL in a .env file. Or we could use SQLite, or we could just hard code Postgres right here. We're going to have our create engine, session local base, and our get DB, which creates a database session. And then we're going to have this DB session, which equals our dependency injection DB session that we can pass into functions. So just for practice, let's go ahead and create a new file called .env. Now, .env files are often a way for you not to have to pass in your private secret information into a source code repository. So what we could do is instead of passing this directly into code, we could create a new thing called database URL, which is going to be equal to something. And we can just grab this information, paste it right here. And now I'm going to comment out this as well. And I'm going to uncomment here. So what's happening right now is we are grabbing the database URL from a .env file, and we're making sure that's set as our database URL so when we create our engine. Now let's go ahead and create a new package right here called auth. And inside our auth, we're going to create a new file of underscore underscore init underscore underscore dot py. And now is when we're really going to start seeing this clean architecture design, where we're going to have a controller which consumes an endpoint, a service which does the business logic, and then the models, which is the Pydantic data validation schemas. So inside here, let's go ahead and create a new file of controller.py, a new file of service.py, and a new file of model.py. We're going to go backwards from the model to the service to the controller just so we can see how it's created. So what are the models that we're going to need? Well, we're going to need a UUID and Pydantic as imports, but we're going to really just have a couple different ones for the authentication, which is to register a user and to be able to sign in a user. So to register a new user, we need a email, a first name, a last name, and a password. And then we're going to do whatever we need to do with that to save it to a database. We need a class of token, which just returns the token back to the user for authentication, which returns an access token and a token type, which is going to be like JWT bearer token. And then we want a class token data, which is what are we going to give back to the user once we validate a token. In this standpoint, we're going to get their UUID so that we can fetch whatever information we need for that user based on their primary key. Let's then jump into our service.py, which this is going to start having quite a bit of data here, where we are going to have a secret key and a secret algorithm. Again, we can move that into a .env file just like we did with our database core. And I kind of showed you how to do that, so feel free to go ahead and do that. This is definitely something that you're going to want to keep secret and probably not push around in, different repositories. We're going to say the algorithm is HS256 and then the access token expires is 30 minutes. So our token is going to expire in 30 minutes. OAuth2 bearer token is going to be inside our auth.token path. So this is our, which we haven't created yet in our controller, but it's going to be /auth/token. And then our bcrypt context, we're going to be using bcrypt as our hashing context. So we're going to be saving all of our database passwords as a bcrypt hash. We have a couple functions here like verify a password, where we're checking the plain password a user passes in with the hashed password to make sure that they're validated. We're going to be able to fetch hash passwords, and we need to be able to authenticate users. So if a user, passes in their email and password, we want to be able to query by that user, fetch them, verify that user. If it fails, well, then we're going to log a warning for anybody to see in our actual logging of our application, which says failed authentication attempt for the specific user that tried to log in. If not, we're just going to return a user, and you'll see that we have this authenticate user getting called below. We have our create access token, which is our JWT code, which takes in a sub, email, ID, and expiration date. And then we encode that JWT with our secret key and algorithm. So to make it valid, we can then verify a token, which returns a models of token data. So if we look up here, we can see that we're importing our models. And then we have our payload, our user ID. We return the token data if everything works out, or we throw a warning and we throw an authentication error of token verification failed. Same thing for our register user. We're passing in a new database session. We request a user's register request. We validate it and do everything that we need to do for that. And if not, we throw a registered user and we log it. We can get our user, this is what we're going to be using for our dependency injection for validating current users when we're trying to deal with to-dos. We have this as an annotation now to fetch the current user, which is going to get our current user. And then we have our login for access token, which just takes in a username and password. And we just, hey, does it check out? We call different functions or we throw an error. And then what we want to do here is add in our controller, our router for our API routing, which we're saying you can only call register user 5 times an hour. So we're like, hey, you just can't sit here and just keep creating new accounts over and over again. We're going to, slow it down. Now this request looks like it's not being used, but it's required for our rate limiter to fetch the IP address. And then we also have a login function, which returns the token. Now this is from rate limiter. We need to make sure this is from rate limiting. And perfect, that's how we're going to implement our auth. We're then going to create a new folder called users. Inside users, we want the same exact stuff. So we're going to say underscore underscore init underscore underscore dot py. We also want to say controller dot py, service dot py, and model.py. Let's start with our model.py, where we're going to have a user response, which is going to have an ID, email, first name, and last name, and a password change of our current password and new password confirmation. So a user, once they log in, so once we hit the auth endpoint, we log in a user, we're going to return a JWT token. And then when a user tries to log in, we'll grab the user token. So when a user logs in, they're able to fetch information about themselves. Well, they can't fetch all the information we save in the database, like their password, because why would we just give that out to people? But what we will give them is their ID, their email, their first name and last name. And then we're also going to allow users to be able to change their password. So you can pass in your current password, what you want your new password to be, and then kind of the confirmation for the new password to make sure the passwords match. And these are going to be the base models for the Pydantic data validation that we're going to be using here. Inside our service, we're going to say get user by ID, where we pass in our database session. And then here we can just kind of fetch our user, and we're going to say get user by ID. We're going to fetch that user. And then if everything works out, we're going to return our user as a user response. So a user can say, hey, I want to fetch my information by my ID after I validate that I'm the actual user. And then we'll have change password, which takes in the database session, the user ID, and our password change model that we just created in our model, where we can fetch the user by their ID. We can verify their passwords are the current password. So the password that they typed in, is that really their password? Do the new passwords match? So the new password and the new password confirm. And then we can finally update the password at the end. And then lastly, in our controllers, we're going to have it prefixed as /users, where we're going to have our current user as our current user. And we're going to get our user by the ID, and the same thing right here. Perfect. And now let's go ahead and check out our to-dos. So we can create a new folder called to-dos, where again, we're going to do the exact same thing of __ init __ .py. Then we want to create a new file called controller.py, a new file called service.py, and a new file called model.py. Now inside here, we can just paste some information. We can say we want our to-do base, which is going to be like if you want to create a new to-do, description, due date, priority. Create is going to use the exact same thing. And then our to-do response is just going to have our ID is complete, completed at. And then we're going to say, hey, we want this model configuration to be config dictionary so we can consume and use the data a little bit easier. Let's then jump into our service, where we can say, hey, we want this to be create to do with our current user token data DB session to do model.create, where we've done this a ton of different times, where we're just passing in data and we're creating a new to do, log it if necessary. Same thing for our to do get to do. So based on an authenticated user, fetch all the to dos based on the UUID. Get to do by ID, so we can just pass in the UUID after we verify the user, fetch the specific to do by its ID, return it back to the user. Update a new to do, which allows us to be able to just update to dos. And then we have complete to do, which makes the is completed value the opposite, so true or false, and then we save it to our database. And then we have our delete to do, which allows us to delete a to do. And then lastly, we have our controller, which allows us to be able to call each of those endpoints. So like create a new to-do, get to-dos, get to-do, update to-do, complete to-do, and delete to-do, all based on validating a specific user. Now, one thing that we are, and this is all model. Let me just go through this real quick. And now one more thing that we want to implement is exception handling. So we can see like in our service, we're throwing some exception handlers. And let's just go into here, create a new file called exceptions.py. And here we just want to add some exceptions. So our to-do error, to-do not found, to-do creation error, user base error, and we're just doing a super call back up to the initialization of the error that we're calling beforehand. And this is just to allow us to be able to see a little things a little bit cleaner, be able to throw different status codes, and be able to kind of just be able to scale our application a little easier. Now, the last thing I'm going to add here inside our source, and I'm going to say new file. I'm going to name this API.py, where we're going to add now all of our routers right here. And then in our main.py, we already have register app, register routes. We can go over here and just say, hey, we want to register our routes of our app. And then we also want to make sure that we add our configuration for us to be able to throw some logs and then add them right here. So with everything that we just added, if we jump into our terminal and we say uvicorn source.main:app-reload, we're getting an error inside our source.auth. Oops, cannot import models. Oops, where am I saying models? That should be model. That is my bad. And we're also doing it in here. Yeah, that should be model. See, even when you think you have everything planned, coding can throw some errors at you. Oh goodness, I did it in all of them. All right, let's go back into users. It should be model. Model. All right. Now everything should be good. All right. So now if we open up our application, we go to our port. There it is. Here's our whole application. Everything looks great. And if you try and get something, it's going to throw a not authenticated because you have to register an account and then grab the token, stick the token up here to be able to handle all the endpoints. But now let's go over how we can test this application. So there's two ways we can really test it. We can test it with unit testing and we can test it with end-to-end testing. And how we can do that is let's jump into our source. Let's go ahead and say new folder. Oops. Let's jump outside of our source, and let's create a new folder called tests. And now inside our tests, we want to create a new __ and init__.py file. And the first thing we're going to create in here is something called a conf test file. So conf test.py. This is more of like all the stuff to get our application ready to be tested. So here we know this is actually that, and this is limiting. But what we're doing here is we're just setting up a fake SQLite test or SQLite test database for our application. We're doing everything we need. So we're setting up all of our entities for our test database. And then we're just setting up our PyTest fixtures, which are more or less ways to set up data for our tests to be called. And we're doing that all over in here. First thing we're going to do is our auth test service. So we can come in here and we can say test auth service.py, where we just add in all of this information, where we're going to be able to test against our verify password, authenticate user, test login for access token, be able to create a user, or testing against everything inside our service. We can come over here and create another file called test_users service.py, where we're just adding everything inside of here, where we're now going to be testing our get user information and then be able to change a password. And we're testing really every way someone could try and change their password and making sure that all of our configurations are correct. And then the last thing is our test to-dos. So our test_to-dos service.py. We want to make sure all these are good. So here, there's a whole bunch of different tests about creating a to-do, getting to-dos, get to-dos by ID, completing to-dos, deleting to-dos, everything we need there. And really what we need to do here is we can just say PyTest. If you run PyTest, we can see our tests start running and everything looks good. We have all of our things passed. We can ignore this right now. It's saying something is going to be potentially removed in the future, but it doesn't matter because a lot of times these deprecation warnings last way past the version date, or sometimes they don't even ever get fixed. So that's okay. We can see that all of our tests pass and we have our test DB. But now we want to do end-to-end testing. So what that means is we are starting at the endpoint and we're testing everything down and everything back from the endpoint. So inside our test, let's create a new file called E2E, which stands for end-to-end. And I'm going to say new file of test_auth_endpoints.py. This is now going to test all of our endpoints, literally calling the endpoints. We can say we're calling the auth/token. We're calling the auth/token again. We are doing our endpoint testing all the way down to our service and back instead of just our services. We're going to do the same thing here for test underscore users underscore endpoints dot py. And this is going to test everything about a specific user based on the endpoint all the way down. We're testing, hey, are we getting the right status code? Are we getting the right responses? We're just making sure that everything looks really good. And now lastly, we want to say test underscore to-dos underscore endpoints, where again, we are just testing everything from a to-do perspective based on the endpoint. So awesome stuff. Let's go ahead and just do PyTest again. And now we should be testing all of our endpoints as well. And this percent over here is just like it's incrementing up to 100%, where 100% is done. That's not like code coverage. So now we have all of our tests passing. Cool. So now if you remember, we added our Postgres right here, and we want to make sure that that is like the new information. So I'm just going to say source.env. From my standpoint, that sets all the environmental variables for my local environment. But what we want to do now is let's deploy all of this on Docker. So if you don't already have it, go ahead and download Docker from your application. And here you can see that I don't have very much installed on my Docker at the moment. And what we're going to do here is make sure that we can run our application from Docker, and then also Postgres will be created in Docker. So we're going to deploy our application on Docker, and we're going to deploy our Postgres on Docker. So the very first thing we need to do is create a new file inside our main thing called a Docker file. And inside here, we're saying use Python 3.11 from our work directory of app. We're going to install our requirements.txt. We want to copy the project files of our source, and then expose on port 8000 using our command that we use to run our application. And now we need a Docker compose.yaml file, which is going to do everything else for us. So right here, we can see that it's going to spin up a Postgres environment, which is going to be called clean FastAPI on our port. And we already set this information up in our Docker, in our database core file. And then we're going to deploy this Postgres environment. So we're going to deploy our Postgres environment, and we're going to run our FastAPI application. And we can do that by saying docker compose up -- build. When you do this, it's going to pull the image from the latest Postgres if you don't already have it. It's going to spin up that Postgres environment, and then it's going to deploy our application. Our application is going to be communicating with that Postgres environment. So it says application startup was complete. If we come back over here and we refresh, this application is literally running from a Postgres database now in our Docker environment. If we open up Docker, we can see right here, we have our Postgres running and our product running. If we but it's all in the same container. So if we just want to stop it, we can just stop that container. And our application crashes just like expected because we turned it off in Docker. So awesome stuff, guys. This is, I know this was a lot. The code is, you can download the code directly under descriptions. I just kind of wanted to walk through what exactly is happening in case you wanted to, dive more into it. So you can scale and build from here. This is already a very professional application, which is using Docker tests, end-to-end tests, unit tests, structured in a way to really scale our application. So use this how you like. I hope you enjoyed it, and I will see you in the next video.